Welcome students in our PMI chapter. Continue exercise 4. I hope students you understood in the last 3 videos our basic rule for PMI, step 1, step 2 and step 3. Yes students, the same concept related. Today also I am moving ahead our 15th sum. PM given in this part and we prove by PMI, principle of mathematical inductions. Yes students, it's very easy. Step 1, if n is equal to 1, every time you start n is equal to 1. So what's your LHS? 1 square. Only put down first step. And RHS, n with 2n minus 1 with 2n plus 1 by 3. And successfully apply n is equal to 1. So you are getting just here 1, 2 minus 1, 2 plus 1. You get 1, 1, 3. It's 1 only. So LHS is equal to what? RHS. It means P1 is true. So now I am going to step 2. If Pk is true, so what is the P of k? Overall equations. Again I write down 1 square, 3 square, 5 square, 2k minus 1 and is equal to here same k, 2k minus 1, 2k plus 1. Only here I change in the k by 3 same and step 3 which is 2 proof. Students necessarily write down that type sums. It is a theoretical numerical, not MCQ. So P of k plus 1 which have to 1 square, 3 square, 5 square. Yes students, here one turning point. That is the main step. 2 k plus 1 minus 1. Here same k plus 1. 2 with k plus 1 minus 1. 2 with k plus 1 plus 1 by 3. Yes students, this is the main step. Now easily going to LHS our solutions. So my LHS is what is LHS? 1 square, 2 square, 3 square, 5 square till last. That is 2 with the k plus 1 minus 1 whole square. Just you think out to one reverse term, one back step. Yes students, you correct thinking about that. What you think? Here k plus 1. Only write down the k. Minus 1 same as. So here 2k minus 1 and this step is as it is. Nothing to that. And this term are our step number 2. And the answer is known. Which have 2k, 2k minus 1, 2k plus 1 by 3 and here as it is by 1. And you declare because Pk is true. I mean students, I am checking about 2, it is step 2. Now this simplify happily, easily done. So here k, remaining parts by 3 and here how many? 2k plus 2 minus 1, it means plus 1 by 1. Now we take out students maximum common and simplify it up to our RHS. So now I am going ahead, just common taking in that. That is my RHS. Yes. So now what is the common? Maximum common 2k plus 1. Remaining are k, 2k minus 1 by 3 and here 2k plus 1. Now we calculate further easily. 2k square minus k. This 3 multiplies 6k plus 3. And downwards is same as. So 2k square plus 5k plus 3. Yes, it's done. 3 2s are 6 and I want 5. So splitting same, 3 2s are. It means 2k plus 1 plus 2k plus 3k upon same. So 2k common, k plus 1 plus 3 common, k plus 1 and upon 3 is as it is. Now students, I just simplified at the length of these sums. These are the last stage. So 2k plus 1, 2k plus 3, k plus 1 by 3. Check. That's your RHS. Yes, check about 2k plus 1. This how much? 2k plus 2 minus 2. This is 2k plus 1. And this how much? 2k plus 3. It means done. Therefore, P of k plus 1 is true. It means if Pk is true, then P of k plus 1 is also true. So last write down my PMI, this numerical, is true for every and belongs to natural number. Now students, I am going to one more question. 16 is also very easy numerical. Step 1. If n is a good one, you check out here LHS. 1 by 1 into 4 and RHS n by 3n plus 1. Just I put down n is 1. 3 into 1. Yes, it's the same. So, LHS is equal to RHS. It means P1 is true. Now, we are going ahead. Step 2. If Pk is true, so what is the P of k? Students, this whole equation, again, we can write down in the terms of k. So here 3k minus 2 into 3k plus 1 is equal to k upon 3k plus 1. Now same explanation by step 3. To prove P of k plus 1, same showing 1 into 4, 4 into 7 and here this is a main turning point. Again I repeat to you students, this is a main turning point. Every time k change in the terms of k plus 1. So here 3 times k plus 1 minus 2. Here plus 1 and is equal to what? K plus 1 by 3. K plus 1 plus 1. Indirectly we checking about that. It is k plus 1 by how much? 3 plus 1, 4, and that's my last target. Yes students, now I start LHS. 1 into 4, 4 into 7, 7 into 10, plus. These are completely steps, same as I showed that 1 by 3 with k plus 1 minus 2. Nothing calculate. First of all, you write down the back step. After that, calculate. 3 with k plus 1 plus 1. And now students, think out to one back term. Yes students, here your one back term is ready to in your solutions. And easily you can move in your answer by that. So, the steps I again continue. I will just moving ahead up to that. Now, what is the back term here? K plus 1, only k write down, which is 3k minus 2. Here 3k, only k plus 1, we can show k. plus 1 is same, and here also same is k plus 1 minus 2 and k plus 1 plus 1. Yes, now students, this full value up to that, you know that it is what? That is your step 2. Yes, k upon 3k plus 1. So in that place, I just write down that is 1. K below 3k plus 1, and here same is 3 with k plus 1 minus 2, 3 with k plus 1 plus 1. And side by side, we can show here utilize for pk is true, and that principle I apply that. Now students, k upon 3k plus 1. Now you calculate, not here calculate, here for expansion. It is 3k plus 3 minus 2 plus 1. 3k, 3 and 1, 4. Yes students, now take out LCM, either common. You easily common checking and finished our sum. This is my answer. Yes. So, what is the common? 1 by 3k plus 1. Remaining are k. 1 by 3k plus 4. So, indirectly, we can conduct that 3k square 4k plus 1, and now splitting 3 ones are 3. I want 4. So 1 by 3k plus 1. Here 3k square, 3k plus 1k, and that's the easy. So finally we can take these steps. 3k common, k plus 1, plus 1 common, k plus 1, upon 3k plus 4. Now students, we take out the common. So 1 by 3k plus 1. Here common is a k plus 1. Other are 3k plus 1 upon 3k plus 4. Check, that's your version. That is your step RHS. So after that you write down this and write down this and show here RHS. So we can say P of k plus 1 is true. So if pk is true, yes students, finally must be write down the last 3 lines. pk is true, then p of k plus 1 is also true. And last write down, so by Pn is true for every and belongs to natural number. Now students, continue same examples. I go into question number 17. Not example, it is exercise questions. Yes students. Similarly going ahead, step 1. If n is equal to 1, we can show here LHS. 1 below 3 into 5, it is 50. It is not a pointer, it is a multiply. And RHS, n upon 2n plus 3. You can just write down n is 1. N is 1. 5 and 3, 15. So definitely we can write down LHS is equal to RHS. So P1 is true. Now students, happily first step over. Now I am going to step 2. It's also same solutions. If pk is true, so what is the p of k? These 4 equations. Again I just write down 1 by 5 into 7 plus here similarly 2k plus 1 into 2k plus 3 is equal to k upon 3 2k plus 3. Yes students. Now step 3, which is to prove. I hope now you understood the all steps properly. Yes students. It's now easy chapter, no? Yes. In first part, you think about which type of chapter easy or not, but it's a very easy numerical. So here 1 below 5 to 7. Only this I change. K place K plus 1. So I just write down properly 2 K plus 1 plus 1. 2 K plus 1 plus 3 and is equal to how much? 3 with the 2 K plus 1 plus 3. This answer. If you further calculate, definitely we can 2K 2 plus 3 5, and that is my last stage for this numerator. Now I start slowly our LHS. Yes students, what is the LHS? The same as I bring down there, 2 with the K plus 1 plus 1 and 2 with the K plus 1 plus 3, and this LHS value I just write down 1 back term. Yes students, this back term you easily understood that, and that is your main step, and after that utilize your step number 2. Yes students, this back steps I again write down that all values, and your back step is a 1 upon 2. This is change. 1 value less is only K plus 1. Here 1 value less and plus the same. So 2K plus 3 and the same is K plus 1. Yes students, I hope you understood. Only one reverse term I write down, and these are, it is your step 2. I know? Yes. How much? K below 3 to K plus 3. And this is the same as 1 upon 2 with the K plus 1 plus 1 into 2 with the K plus 1 plus 3. Students, here I again repeat you, don't take direct steps, step by step way. And we have mentioned because PK is true according to your step 2. Now we going ahead to simplifications. Now we simplify and easily did this sum. So K, 2K plus 3. Here 2K, 2 plus 1, 3, 2K, 2 plus 3, 5, and common checking. What is common? 2K plus 3 common. Remaining are K by 3, 2K plus 5, and now take LCM. Yes students, and same way as we calculate, easily done this sum, and that is my RHS, this steps. So I just as it is. So 1 below 2K plus 3, 2K square, 5K plus 3, and here 2K plus 5. Students, here I check LCM and simplify. Now 3 2s are 6, 5K splitting. So 2K square, 2K 3K by 2K plus 5. Now just you common take out. So 1 by 2K plus 3. Here 2K common, K plus 1. 3 common, K plus 1 upon 2K plus 5 same as. I hope students you understood. Now here K plus 1, 2K plus 3 upon 2K plus 3. 3 times 2K plus 5, and students this are cancel, and other is your answer. K plus 1, 3 with the 2K plus 5, check. Yes, that's the answer. It means we can say P of K plus 1 is true. Therefore, if Pk is true, then P of K plus 1 is also true. And here students, our this part is easily this numerical by PMI. Students, these three lines are compulsory write down in every numerical for PMI. Now I am going to next numerical. Now students, we are going ahead. Question number 18 is the most IMP numerical. So you pick mark in your notebook. Is the most IMP because here given less than means it is an inequality. It means this numerical pattern same, formula same apply, but I calculate in inequality. It is less than, more than, less than, more than, both are inequality. Yes. So students, I start first of all step 1. If n is equal to 1, you never write down here LHS, RHS. Why? Because here not given equal. So we cannot showing LHS equal to RHS. Numerical I prove, but without is equal to. Here not given the is equal to. So we cannot say LHS and RHS. Only write down n equal to 1. So this is first term and this is your last value. 1 less 1 by 10 plus 1. Whenever you not equal given, then you write down that steps. And here putting n is 1. So students, you getting here 9 by 8. 3 square and multiply it. Check. 8 less than 9? Yes, it is true. So, this step is also true. Therefore, E1 is true. Now, I am going ahead. Step 2. What is step 2? If Pk is true. So, what's your P of k? Full equations. Again, I am showing that in the terms of P of k. So 1 plus 2 plus 3 plus k. Look at that here. Less than 1 by 8. 2k plus 1 whole square. And now step 3, which is to prove. So that's the method are same. Step 3, similarly step 2 and step 1. What is step 3? To prove P of k plus 1. So this total are. I just show out that here k plus 1 less than. Here also 2 times k plus 1 whole square. You know, it is a proving 2k plus 2 plus 1. Indirectly 2k plus 3 whole square, and that's my proving. Now I start our solution. Yes, that is my part, left hand side part, but we don't write down LHS. So I just showing around 2 for 1 plus 2 plus 3 plus k plus 1 is equal to. Yes, here I think about 2. One back step. I mean one back term. Which is a back term? 1 plus 2 plus 3 plus k. And here k plus 1 same is. Now students, this value 1 to k, you know that, which is step 2 in less than. So here I write down less than 1 by 8, and that's the same. And here completely write down similarly full term k plus 1. And mention properly from step 2. Either we can write down pk is true. That's why I mentioned here less than 1 by 8 to k plus 1. Now this constant going to same is still last full equation. This is students. Here I am not showing LHS and RHS because it is not equal given. This is equal. But now they convert it to less. Utilize step 2. Now students, here I am choosing the LCM. 2k plus 1 whole square. 8 with k plus 1 by 8. So 1 plus 2 plus 3 plus k plus 1. And now here expand. write down k plus 1. And here total 4k square. 12k plus 9 by 8. And again after that, we can go in there. It is 2k plus 3 whole square by 8. Sure, it is 2k plus 3 because the perfect square. And this value is that 2k plus 2 plus 1. Yes, students, here I just show out my step. Now I just ending after that my last 3 lines. So what is the last 3 lines? After the proofing, we can say therefore P of k plus 1 is true. Therefore, if Pk is true, then P of k plus 1 is also true. And last write down. So by PMI, Pm is true for every n belongs to natural number. Yes, students, here our this numerical is happily done. But one more time I repeat, this is an IMP question because that here less than given and less than term I utilize here. These and that are same. One back step after that. But this term I utilize from step 2. Less than 1 by 2k plus 1 whole square. And now after the simplify. But this last part, this right part, necessarily you write down in your notebook. Till up to that. Then that is true. And now last step is easily we can show that. Yes, students. Here this numerical is done. Yes, students. After ending this numerical, this part is end here. Further explanation, students, I explain you in the next part by the next new our topic. Yes, students. PMI continue, but topic is not different level numerical. I explain you in the next part. Okay. Bye bye. See you.